We're going to get more into Lewis symbols in the next unit in chapter 2. But for now, I just want to tell you that the electrons in atoms are arranged in what we call shells. You know, different atoms have different numbers of electrons depending on the number of protons. And those electrons themselves are arranged in kind of shells. And sort of like an onion, layers of an onion. And the outer layer of electrons on an atom is called the valence shell, or the valence electrons. All right? And there was this symbolic way of representing the electrons that are in the valence shell that somebody who was a professor out in California, his name was Gian Lewis, came up with a long time ago, where you just arrange dots around the symbol of the element to indicate the number of electrons that are in what we call the valence shell. And so one dot indicates one electron in what they call an orbital, 2 dots, 2 electrons. So hydrogen just has 1 valence electron, so we would make its Lewis symbol like that. Helium has 2, doesn't matter which side you put it on, I have more space over here, I'll put it there. Nitrogen has 5 valence electrons. How do I know how many valence electrons are in these elements? Well, as it turns out, the periodic table is a guide. And again, we're going to come back to this electron configuration in the next unit, but for now, to really understand ionic compounds, you need to know one simple thing, and that is that group 1 elements have 1 valence electron, group 2 have 2 valence electrons, group 3A have 3, etc., all the way up to group 8 have 8 valence electrons. All right, and what happens is the metals in group 1, 2, and 3 tend to lose their valence electrons to form ions. So if group 1 loses 1 electron, it's going to form an ion with a +1 charge, like the example we saw with sodium. Group 2 metals are going to form ions with a +2 charge because they're going to lose their 2 valence electrons. And group 3 metals are going to lose 3 electrons. All right, the nonmetals in groups 5, 6, and 7 tend to gain electrons. All right, and so how many electrons do they gain? Well, as it turns out, this group out here are the noble gases. Noble gases have, except for helium, have 8 valence electrons. So it turns out 8 is a very stable number of valence electrons. So the nonmetals tend to gain electrons such that they'll end up with 8. So if you have 7 already, you only need to gain 1 electron. So the example we saw, chlorine tends to gain 1 electron. It would have a -1 charge when it gains 1. The group 6 are going to gain 2, so they're going to have a -2 charge. So these will form ions with a -1 charge. Group 6, -2 charge. Group 5, -3 charge. Again, I'm telling you this just so you can understand a little bit better the formation of ionic compounds. We'll come back to the details of how the electrons are arranged in the next unit. All right, so to be quick about it, you can tell the Lewis structure, you can predict the Lewis structure by finding where on the periodic table the element is, and then you can say what the valence electrons are based on the group that it's in, and then you can draw a little symbol. So oxygen is in group 6. 1, 2, 3, 4, 5, 6. So it has 6 valence electrons. Sodium is in group 1, it has 1. Chlorine's in group 7, so it has 7. Potassium is in group 1, it has 1. Magnesium is in group 2, it has 2. Okay? So you can use Lewis symbols to work out the formulas of ionic compounds, and that is on one of your worksheets that you can do in your class. There's lots of worksheets to go with this particular activity. So I don't want to take a lot of my time because I have limited time to go through this part 1 of video 9.